Hello?
Hello, can you hear me?
Yes?
Okay, so have you tried the questions here in chapter 5?
Yes.
Tell me which ones are not solved or yet, anything that is a problem.
Yeah. Uh, I was I was struggling with question 74. Uh,
Okay, right. So the question is if each of two intersecting lines intersects a hyperbola and neither line is tangent to the hyperbola, then what are the possible number of places where the lines can intersect the hyperbola?
yeah.
So So let's take a hyperbola like this, and we have two lines which are intersect the hyperbola. Each of two lines intersects the hyperbola and neither is tangent to the hyperbola. So let's draw one line which intersects the hyperbola.
Okay.
This can intersect the hyperbola here and here, 2 points. It is not tangent to the hyperbola right now. You need to realize that the asymptotes are the special lines which are tangent to the hyperbola at infinity.
Yes.
So this is my hyperbola, and the hyperbola will always lie between these asymptotes, right?
Yes.
The curve is always between the two asymptotes. This is asymptote 1, this is asymptote 2, right?
Yes.
And the asymptotes are touching the hyperbola at infinity point. So our two lines, one line can be like this. It can be anything as long as its slope is between this asymptote slope and this asymptote slope. Then it will intersect.
Yeah.
If the line was such that its slope is larger than the asymptote, right? Then it will
Yes.
intersect. Again, notice that it will intersect twice then.
Yeah.
So the total number of points of intersection can be 4, right?
Yes.
Each line can intersect the hyperbola 2 points, and there are two lines, so there will be 4 points total. But we have not thought about the case where the line could be parallel to the asymptote.
Uh,
Like, for example, this is my hyperbola.
yes.
Let's think about the asymptote like this. This is the asymptote. If you make a line parallel to the asymptote, it will cut here once, but this side it will not touch because this line is coming close to the asymptote. No? The
Yes.
hyperbola is coming close. They are meeting at infinity. So this will not touch anywhere, right?
Yeah.
So
Right?
if you have lines which are parallel to the asymptotes, lines parallel to asymptotes, then it is possible to cut the hyperbola only once.
Oh, yeah.
But if you are not parallel to the asymptote, if you have any other type of line, you will cut twice.
Yes.
So one is also possible, and one is possible for both the lines, right?
Yes.
So it is now possible to have three or two or four, right?
Right? Yeah.
One point of intersection is not possible unless both the lines are identical and they are the asymptote, right?
Yes.
In that case, there is only one point of intersection if both the lines are identical. But usually you say two or three or four are the possibilities depending on the lines being parallel to the asymptotes or not parallel to the asymptotes. If they are not parallel, they cut twice. If they are parallel, they cut once. Right?
Yes. Right.
So that is what you have to do.
Okay.
What is the next problem?
The next one is chocolate. Question 77.
Okay. If the line y is equal to mx plus 1 intersects the ellipse exactly once. Intersects the ellipse exactly once. So basically, ellipse equation is x squared plus 4y squared is equal to 1. And this
Yes.
line intersects the ellipse exactly once. We have to find out m square. So first of all, it is not possible to intersect the ellipse once. The only way it will happen is if the line is tangent.
Uh, yeah.
If you are not tangent, then you will always intersect twice, right?
Yes.
This can be called as one intersection. It's actually touching. Therefore, there's a double point here, 2 points which are exactly identical.
Yes.
So the condition for intersecting only once is that line y is equal to mx plus 1 is tangent to the ellipse x squared plus 4y squared equals 1. And how do we understand that situation? What can we do about that? So
Uh,
usually when you try to find intersection points, you have to solve the line equation with the curve, right?
yes.
If you have tried to solve this line equation with this curve, you will get two different points, right?
Right. Yeah.
So those 2 points will be the roots of that equation, right?
Yes.
But if I want to make it tangent, I will say that the two roots are identical, two roots are equal, right?
Yes.
I will solve the line and the curve and I will say that the roots are equal. Under that condition, the 2 points of intersection are not 2 points, they are simply 1 point and it is a tangent.
Yeah.
So our thing is to solve this line with this curve. So what I will do is I'll take y is equal to mx plus 1 and I'll put it in this equation. I'll get x squared plus 4 times mx plus 1 whole square equals 1. And this equation, I will simplify it a little bit. X square plus 4 m square x square plus 4 plus 8 mx minus 1 is 0. And you are getting x squared common 1 plus 4m square plus 8 mx plus 3 is equal to 0. Right?
Yeah. Right.
If this equation had two different roots, then the line would be cutting it at 2 points, which is not what we want. We want the equation to have two equal roots.
Yes.
Then only it is tangent. So for equal roots in a quadratic, we can say discriminant should be equal to 0. So this is a quadratic equation. I will say that the discriminant of this quadratic must be 0 for equal roots. So I'll get 64m square minus 4 times 1 plus 4m square times 3 is equal to 0. So I'll get 16m square minus 3 minus 12m square is equal to 0. So 4m square is equal to 3. Therefore, m square is equal to 3 over 4.
Yes.
If m square is 3 over 4, in that case, the line will be such that it will be tangent to the ellipse. Otherwise, it will cut the ellipse at two different points, right?
Yeah. Right?
So that is what you have to do here, and that's a general technique. It is valid for any two types of curves. If you want to say a line is tangent to a curve, you need to solve the line with the curve and say that the roots must be equal at the point of tangency. Or
Yeah.
you have to say that there are two equal roots at that point of tangency. That condition will give you the condition for tangency.
Okay.
What is next?
Uh, Next is question 80.
Okay. A point P lies in the same plane as a given square of side 1 lies in the same plane as a square of side 1. Now, vertices of the square are A, B, C, D. Distances of P from to A, B, C, and D are U, V, and W, A, B, C. What is the greatest distance that P can be from D if U square plus V square is equal to W square? Okay, so let's think of a square ABCD. A, B, C, D. It will be useful if we take all the points as convenient points, like we can take A as the origin, then B will be 1
Uh,
comma 0, C will be 1 comma 1, D will be 0 comma 1, right?
yes.
P is somewhere, this is the y-axis, this is the x-axis. P is somewhere in the plane. Let's say it is somewhere here, x comma y. The question has said that the distance of P to A, B, and C is known as UVW.
Yeah.
So this distance is U, this distance is V, this distance is W. And we know that U square plus V square is equal to W square, right?
Yes.
You have to find the maximum possible distance from D. So
Yeah.
let's call this distance T. We have to find T max.
Okay.
Okay. They have given us this condition. U square plus V square is equal to W square. Okay.
Okay.
So, okay, so the T value is coming out to be x square plus y minus 1 square. And this equation looks like U is going to be x square plus y square, right?
Yes.
U square is this, V square is x minus 1 whole square plus y square is equal to W square, which is x minus 1 whole square plus y minus 1 whole square, right?
Yes.
X minus 1 square gets cancelled one time, and we have x square plus 2y square is equal to y square minus 2y plus 1. So 1y square gets cancelled, and we are getting x square plus y square plus 2y minus 1 is 0,
Uh,
right?
yes.
So we are from this condition, we are able to get a relationship on x and y where x and y are the coordinates of point P. So technically we have gotten the locus of P, right?
Yes.
And if you think about this is clearly a circle. You can say x square plus y square plus 2y plus 1 minus 2 is 0. And this is x square plus y plus 1 whole square is equal to 2, right?
Yes. Right.
So the center of the circle is 0 comma minus 1 center. The radius of the circle is root 2, correct?
Correct. Yeah.
So now that we know this, we can say that any point on the circle, we'll think of parametric form. Center of the circle is
Okay.
0 comma minus 1, radius is root 2. Any
Yeah.
point on the circle with center h comma k and radius r, any point on the circle with center hk and radius r would be given by x is equal to h plus r cos theta and y is equal to k plus r sin theta, where
Yes.
0 is less than theta is less than equal to 2 pi. This is a standard information. This is called parametric form or polar coordinates. You are saying
Okay.
that if this is h comma k, this is r, this is theta, this is r cos theta, r sin theta, but shifted from h comma k. So technically it is h plus r cos theta and k plus r sin theta. If h
Yes.
comma k was the origin, I would just write r cos theta, r sin theta, right?
Right. Yeah.
So here the center is 0 comma minus 1. So any point on this circle
Yes.
is basically going to be 0 plus root 2 cos theta and minus 1 plus root 2 sin theta,
Okay.
correct?
Correct. Yeah.
So this becomes minus 1 plus root 2 sin theta. This becomes the point on the circle. Now we have to find the distance of this from D and maximize that distance, right? D
Yes.
point was x is 0, y is 1. So by distance formula, you'll get root 2 cos theta whole square plus root 2 sin theta minus 1. So minus 2 whole square, right?
Yes.
So this will become 2 cos square theta plus 2 sin square theta plus 4 minus 4 root 2 sin theta. So notice that this is becoming what? 6 minus 4 root 2 sin theta, right?
Yes.
And that is the square of the required distance, t square, right?
Yeah.
Now, if you think about it, this value we have to maximize. So, in order to maximize that, sin theta should be minus 1, right?
Yes.
And then you'll get 6 plus 4 root 2 is equal to t square.
Uh, yeah.
So, the t maximum value will be root over 6 plus 4 root 2.
Yes.
What have we done here? We have converted the problem into polar coordinates. We took x as h plus r cos theta and y as k plus r sin theta. And that is the general point on the circle. First thing is to figure out that it is a circle using the condition given.
Yes.
Once we figure that out, using this data, we can find out everything.
Yeah.
Is it clear what is happening?
Yes. It's clear.
Okay, what is the next one?
Next one is Uh, Question 81.
An ellipse is drawn with major and minor axes as 10 and 8. Using one focus as the center, a circle is drawn that is tangent to the ellipse, with no part of the circle being outside the ellipse. You have to find the radius of the circle.
Yeah.
First of all, they have told us major axis and minor axis is 10 and 8. So this distance is known as major axis, that is 2a,
Yes.
that is 10. And this distance 2b is equal to 8. So b is equal to 4 and a is equal to 5, right?
Yes.
Now let's say that so ellipse is centered at the origin. They have not said anything, but we are going to assume it. Because they have not said it, we can assume it's the center of the ellipse is at the origin. In that case, the equation of the ellipse becomes x square by a square plus y square by b square equals 1, right?
Yes.
Usually the equation is written as x minus h whole square by a square plus y minus b whole square by b square plus equals 1, right?
Yes.
That is for the center h comma k. Here the center is 0, 0. So if this
Yes.
is the equation, we can rewrite it as x squared by 25 plus y squared by 16 equals 1, right?
Yes.
Now find the focus of this ellipse. For finding the
Uh,
focus, you need to know the eccentricity, right?
yes.
Eccentricity is root over 1 minus b square by a square, if you remember.
Yes.
So it is 1 minus b square is 16 by 25. So eccentricity is 3 by 5.
Okay, yeah.
If you know the eccentricity, you can find the focus. Focus will be at minus AE comma 0 and AE comma 0.
Yes.
So we already know eccentricity and we already know A is 5. So let's take the focus as this positive focus and the focus will be AE comma 0. So 3 by 5 into 5, so 3 comma 0, right?
Yes. Right?
We need to make a circle like this which touches the ellipse at some point and is always interior, right?
Yes.
Okay. Find the radius of that circle. So you can see from the figure itself that center is 3 comma 0. This distance is 5 comma 0. This is 2, right? 2 units.
Yes.
Any other point on the ellipse, we can see, I don't think the distance will be smaller than 2. We can check it. Uh, any other point on the ellipse? Okay.
Uh,
Technically, we can write any point on the ellipse as a cos theta, b sin theta. Why?
yes.
Because it will always satisfy this equation, right?
Yeah.
A cos theta, b sin theta always satisfies that equation, so it always lies on the ellipse. So now, what we can do is find the distance of this from 3 comma 0, right? A
Yes.
is 5 cos theta and this is 4 sin theta. And find the distance of 3 comma 0 from it. So 5 cos theta minus 3 whole square.
Yes.
This distance is becoming 5 cos square plus 16, so 21. Right. We are getting 21 cos square theta minus 30 cos theta plus 9 square root of that. So notice that 21 cos square theta minus 30 cos theta plus 9. That is the distance that we are getting. And
Yeah.
root 3 common, getting 7 cos square theta plus 3. Okay, so clearly 7 and 3 is a factorization, right?
Yes.
But that won't help us much. We'll get 7 cos theta minus 1 minus 3. You're getting root over 7 cos theta minus 3 multiplied by cos theta minus 1, right?
Yeah.
Cos theta minus 1 is always negative, so this has to be negative. So 7 cos theta minus 3 is less than 0. So cos theta is less than 3 by 7. That much we know.
Yeah.
Because the thing inside has to be real positive. So cos theta is less than 3 by 7, I'm getting.
Yeah.
Right. Okay, so I wanted to do it without calculus, the minimum value, but
Uh,
cos theta is less than 3 by 7. From the figure, it looks like 2 is the minimum radius, but
yeah.
that is obvious. So we have to, maybe that's it. We have to just go with radius is 2. So right now, without calculus, I don't think it's possible to do it nicely. So I want to find the
Uh,
minimum distance of a random point on the circle from 3 comma 0. If that distance is bigger than 2, then we have proved that this is the only possible way circle can touch.
yeah.
Do you understand what I'm saying?
Yeah, understand?
But from the figure, it is obvious that you can make a circle like this, which is tangent at the end point here. Radius of that circle would be always 2, and it will be inside the ellipse.
Yeah.
Okay. Let's move on. Is there any other question?
The last one that could 83 is
83.
the last one that could solve. Yeah.
Okay. A circle rests in the interior of the parabola with equation y is equal to x square, and it is tangent to the parabola at 2 points. How much higher is the center of the circle than the point of tangency? So this is the situation roughly. This is my y is equal to x square, and circle is resting like this such that it is tangent to the parabola at 2 points.
Yeah.
Technically, the graph is symmetrical, so both the points will be at the same level. Y is equal to x square graph is symmetrical perfectly. So this and this point will be at the same level, right?
Yes.
This is the center of the circle. We have to find this height. Do you understand?
Yes.
Okay. So now I know that a line here is tangent to both the circle and the parabola. Correct?
Yes. Correct.
So this joining it to the center, this is 90-degree, right?
Yeah.
Because it is
Right.
tangent. So, okay. So since these 2 points are at the same level, basically it will be like minus x1 comma x1 square, and it will be like x1 comma x1 square, right? These 2 points.
Yes.
Okay. Now I need to say that this distance is how much? It is 2x1.
Yeah.
That's the base of the triangle. So, right. And the circles would be at 0 comma, let's say k. That is the center of the circle.
Yeah.
0 comma k is the center of the circle, right?
Yeah.
Why will be at 0? Because these 2 points will, midpoint will be at 0, no? X is 0.
Yes.
So this is a radius. This is also a radius, right?
Yes.
So what we can say is that the length of the radius is equal to basically the distance between 0 comma k and this point. So x1
Yes.
square plus k minus x1 square whole square, right?
Yes.
Okay. Now we also know that this line is perpendicular to this line.
Yes.
So, no. Okay, so the base has an equation. The equation of the base is y is equal to x1 square.
Yeah.
And drop a perpendicular from the center to that will be the height, right?
Yes.
So drop a perpendicular from 0 comma k to the line y is equal to x1 square. The equation, the length of the perpendicular will be k minus x1 square mod by root over 1 plus 0, so 1 only.
Yes.
So height is equal to this k minus x1 square mod, right?
Yes.
Okay. So, right. And now this distance is x1, right?
Yes.
Height we have written in terms of k and x1. And radius we know is this. That doesn't help us because it will give us the same obvious thing. So we
Yeah.
have to think of something more. The two curves have a common tangent at this point. So, right. Okay, so what we can say is radius is also equal to x1 square. That doesn't help. Okay, one way to do it would be to mm, take a line equation, find the equation of the tangent to the hyper to the parabola at x1 square. That line is also
Okay.
tangent to the circle. So, okay, so what is the slope of this line? Slope of this line is x1 square minus k by x1
Yes.
minus 0. So the slope of my line, the other line, this line, tangent, is going to be perpendicular, so its slope will be minus x1 by x1 square minus k, right?
Yes.
So this is my slope of this line, and the equation of this line would be passing through this point. So equation will be y minus x1 square is equal to m times x minus x1. M is this,
Yes.
x minus x1. This is my equation, right?
Right.
This is my tangent equation to the parabola, correct?
Yes.
Okay. That equation is wait,
Uh,
I'm missing something. 1 second. Okay, one thing that we are missing is the circle and the parabola will intersect at this point. So far, we are saying this
yeah.
point and this point, but we have not yet found what is x1. So,
Uh,
we just assumed these is a variable and we put the points, right? We
yes.
have to find the intersection points because then we can find the height. We saw
Yes.
already that the height is some mod of k minus x1 square, right?
Right.
Because the point here is 0 comma k. The height will be mod of
Ye
k minus x1 square, right? So
yes.
what I need to do is write the circle equation. The circle equation is x minus 0 square plus y minus k whole square is equal to radius square, and radius is x1 square plus k minus x1 square whole square, right?
Yes.
This equation has to be solved with the equation y is equal to x square,
Yeah.
right? Because the
Right.
circle and the parabola are intersecting. So if you put that there, you will get x is equal to x1 from there, plus minus x1. So that we have already
Yes.
assumed. Uh, 1 second. We are missing some simple thing.
Uh,
So we are saying that the center is at 0 comma k. Let's say radius is r.
yeah.
The equation of the circle is x square plus y minus k whole square is equal to r square. And equation of the parabola is y is equal to x square. So these two can be solved to find the points here P and Q, right?
Yes.
So in order to solve it, you'll get x square plus x square minus k whole square is equal to r square. And basically this equation will have two roots which will give me P and Q. So x power 4 plus k square minus 2k x square plus x square is equal to r square. You're getting x power 4 plus x square 1 minus 2k plus k square minus r square equals 0, right?
Yes.
So from here, you're getting x square is equal to minus b. So 2k minus 1 plus minus root over 2k 1 minus 2k whole square minus 4 times k square minus r square by 2,
Yeah.
right?
Right.
So the thing inside the root is becoming 4k square plus 1 minus 4k. So 1 plus 4k square minus 4k minus 4k square plus 4r square. So 1 plus 4r square minus 4k, something like that. So
Yeah.
those are the two values, okay, of x square and all. Then we can say that, okay, so what happens here is the discriminant here, this part here must be 0, because this line is a horizontal line. You will have points like minus x1 square and x1 square. So the value of x1
Yes.
square is common to both, because both the points lie on the curve parabola. No? The
Yes.
y coordinate is common to both. So the only way that can happen, it will not happen if the x values are different, right?
Yeah.
Like if there are two different roots of x in such a way that one x root is smaller than the other, right? Then
Yes.
you will end up with having different y values, right?
Yeah.
Basically, it has to be a situation where there is equal roots.
Yes. Yeah.
So in that case, this discriminant should vanish. If there is a different value here, plus minus, then you will not get a horizontal line,
Yes.
right?
Right.
So if this discriminant vanishes, x square is coming as 2k minus 1 by 2, or k minus half, right?
Yes.
So this level PQ is at the line y is equal to k minus half, right?
Yes.
And then the height of this point was 0 comma k, and this is at k minus half. So the difference in height is simply half, because this is at 0 comma k, this is at k minus half.
Yes.
What is the difference in height? It is k minus half, which
Yeah.
is simply plus half. The point is to
Okay.
realize that you cannot have unequal roots of x. Like
Yeah.
you can have unequal roots of x, but x square has to be same.
Yes.
X square cannot have two different values. The equation was a quadratic in x square, not in x, right?
Yes.
So x square will have a common value, which means equal roots, which means discriminant should vanish, which means x square should be this. And if x square is this, you can find x will be different plus or minus. But that doesn't matter because the level of the line PQ we have found. That is going to be k minus half, and the level of the center of the circle was 0 comma k, so the height is half,
Yes.
right?
Okay. Right.
Okay, the next chapter is polynomials. So you
Mm.
need to go through this polynomials chapter. It is very important, and many problems are there in Olympiads based on this. The first thing that he
Yes.
will teach is division, synthetic division, and things like that. Go through the first few sections, see if you are understanding what is happening.
Okay.
We will try to do as many questions as possible here. Rational roots theorem is there. Descartes' rule of signs is there. All of this stuff is things that we have seen before in some context. So you need to do it fast. And
Okay.
next week, I want to discuss several sections here. Go through all the sections, theory at least, and we will see what you have not understood and what is there that we can work on. But
Okay.
every section here is super important. There is Newton's sums, there is transforming polynomials, which we discussed yesterday.
Yeah.
So similar things are there which you need in your A levels also. So all of this whole
Okay.
chapter is super important. Make sure you do it properly.
Okay.
Okay, that's all for now then.